running a little bit behind schedule, but we will have enough time for the next presentation. We may have to postpone the questions to opportunistic meetings at the end of the conference. It is my pleasure now to introduce Professor Detlev Doherr of the University of Applied Sciences, Offenburg, Germany, and Dean of the Bachelor's Degree Programs, and numerous other titles. His address today will be Hypertextuality in Digital Libraries, Alexander von Humboldt's Visions. Dr. Detlev Doherr is Professor for Informatics and the GIS at University of Applied Sciences, Offenburg, Germany. He has been teaching in the careers of energy system technology, chemical engineering, communication, and media engineering. He is the Dean of the Bachelor Degree Program, head of the Institute of Continuing Academic Education. I won't even try to pronounce the words that come next, I apologize. And director of the Steinweiss Transfer Center of Information Technology. So he asked me to cut his biography short, and I don't want to take any more of his time, but thank you so much for joining us.
Thank you so much. Thank you. Well, ladies and gentlemen, I try to get the microphone. Thank you so much, Brandon, for this nice welcome. Well, I've been contributing to this conference now for the third time, and really it's an honor for me to do that, and especially about this German explorer and scientist Alexander von Humboldt, who gives us a lot of visions, and this is exactly the point of my presentation. Well, I will do my best to give you my ideas across and to give you some presentations about his visions. And I think it is important because he is one who discovered the word phenomena as interactions and interconnectedness, and published his work as a printed hypertext document. I think we could say that, a printed hypertext document, but 200 years ago. This is an astonishing situation. This work may give you a hint how we can adequately reflect information and their complexity, and how we can completely replicate information in digital data. Oh, there's not working. Okay, I have to do this one. Okay, so let me start with a very simple question. In the era of Google Books, why do we need other online archives to provide information? Well, what exactly is so important to recognize in the works of Humboldt more than 200 years ago? Well, it's an actually astonishing fact that Humboldt had the vision of hypertextuality and interconnectedness, and it drove him nearly to distraction that he had no options to order or structurize his publications in a form that properly could reflect his thoughts. An example, you could see here some data about the plant lobelia described and illustrated in different forms, but in Humboldt's publications you could find that, and you see the markings by red cycles and arrows in this slide. Another simple question, how can you find those data by Google search? Can we detect those interconnections there? Well, the challenging answer, of course, is, you all know that, no, we can't. And now the question is, how could we do justice to his legacy and find a way to present exactly those interconnections? Well, since 2001, the web service is provided by the University of Offenburg as the Digital Library, a so-called digital library. And the very start of our project was the cooperation in digital humanities between the University of Kansas, one part with Frank Barron as professor of German literature. We got this idea about the Humboldt publications, and me as a professor in informatics and geoinformatics. This library gave a backup and the background for the new developments in Offenburg, which finally led to a comprehensive Humboldt portal, including all technical features I will describe here in my presentation. So let me make clear, this is an ongoing project, and I cannot give you the final project and the final library here. Well, let's have a look to the internet services. And now the internet provides more than 1 billion websites and makes the accumulated information available to users, regardless of time and location. In the era of digital information, the trend of transforming from data from analogous to digital is increasing enormously. This trend is accompanied by the increase of shared data, which are more pictures and videos than text documents. It's not surprising that the amount of the shareable data people create has grown in the big way over the past decade as social networks took off. An estimation of the amount of digital information indicates that by 2015, people created and shared nearly 8 zettabytes of information. And the zettabyte is the absolute measurement that's equal to 1.1 trillion gigabytes. But again, a simple question. How can we find relevant information? Well, there is an important American company who offers services for searching and analyzing internet data. And so in 2012, Google received over 2 million research queries per minute. Today, Google receives more than 4 million search queries per minute from at least 2.4 billion strong global internet population. But what of these searches are leading to relevant information? And there are a lot of online archives which are out proudly provide scanned documents as libraries, including our Humboldt documents, which you can maybe identify on the right side of this slide. So, what could we do? It's every time the same story. Most students simplify, confuse Google with knowledge. They think when they could find information in Google, they know something about that. Well, but we are exposed to information and we store it in our mind as knowledge. And I'd like to quote the famous German scientist Albert Einstein, that information is not knowledge. The only source of knowledge is experience. Well, I'm considering this statement as a question of how we can make the computer thinking and how we can reach the higher order thinking skills, which are part of the Bloom's taxonomy of learning in computer applications. This is the hierarchical model used to classify educational learning objectives into levels of complexity and mastery named after Benjamin Bloom. Well, as professor and lecturer, I conform to these definitions because all modules in study programs in Germany have to precisely describe the learning outcomes. And according, of course, we call it the Bologna process. Bloom defined knowledge as the ability to recall data and information. He used knowledge as the first level of learning. The second is the comprehension. Comprehension is understanding. Well, the ability to translate, interpolate, or interpret, or restate in one's own words is comprehension. The next level is application, which is the ability to apply something that was learned in the new and different scenario. I wish all my students could meet those requirements, but what could you expect from a computer? Well, now let me come back to Humboldt, because this is the presentation about the Humboldt Digital Library. Humboldt invested a fortune in creating extensive publications and available to a wider public, but complained about the price in the latter. My books have not yet the benefits that I imagined, but I set about editing and publishing them. They are too expensive. Besides the one copy which I own for my personal use, there are only 2 copies in Berlin of my American travel volumes. One of them is in the Royal Library and is complete. The second one, the king has in his private library, but it is incomplete, because even for the king, the installments became too expensive. Well, today we provide free access to digitized documents, or maybe in our digital library, or as links to other digital library, of course, for free. But the vision of Humboldt demands a quantum leap of knowledge management and semantic web structures, which could lead to the kind of information Stuart Brand had in mind. The future libraries, depending on those libraries, should protect our right to know and right to remember. What means that the Internet Archive now is the beginning of the cure, the beginning of complete, detailed, accessible, searchable memory for society. Now, okay, we ask enough simple questions. Let's see what we could do, and maybe something what we could call answers. Humboldt's aspirations to observe all aspects of nature within the context of its interconnections and dynamic processes make it insufficient to our understanding of simply try and learning from digitized versions of his work. Humboldt's desire for an all-facts considering view of the world influenced his writings, and the consideration of details is done in a myriad of notes and cross-references, as you can see here in his travel diary by the marked blocks in the slide which I added there. Humboldt's personal narrative of travel often strays from strictly chronological order, whereas it is the description of a 5-year-long journey to the Americas, remember 200 years ago. After his return to Europe, Humboldt conducted research and often inserted discourses or articles of various length. These digressions make it difficult for the reader to follow the sequence of events in the journey. And Humboldt always spent a network of text and pictures to imitate the complexity of the nature itself. The quote, "Alles ist Wechselwirkung," is attributed to Humboldt, who held the strong conviction that the distinct academic disciplines represented artificial divisions of knowledge, and the key to understand the nature and was interconnectedness. As a result, he published a detailed narrative of his travels, constantly integrating his observations and data from various perspectives and disciplines. So he founded the Humboldtian science, which is the accurate, measured study of widespread and interconnected real phenomena in order to define a definite law and a dynamic cause. Humboldt believed in the importance of accurate measurements and precise descriptions of observations, which should be measured by using the finest instruments and techniques available to better detect processes and phenomena. Well, let's come back to the relevant information. Comprehension of nature as one great whole is the key statement to understand Humboldt's documents. But the complexity and the interconnectedness of information in Humboldt's work are neither visible in his digitized writings nor in document-oriented digitized content. So urgently need a working plan. Yesterday I learned it is more a case study to find the relevant information in Humboldt's documents. We are supposing the concept of interactions as crucial for modeling and adequately interconnecting data by modern information technology. So our working plan looks like that. The functionality of search engines generally doesn't go beyond the textual information. Books are normally digitized as static text in digital files, which are providing searchable information but fail to discover logic metadata or data classification. It is difficult to find relevant information in digital archives without a clue of a text term, phrase, or specific title. So our next step of working plan is to create a table with all documents, in this case from Humboldt, in different languages, different sources, which provides access to Humboldt's documents. You can see here an example of such a table, which is part of our portal project, which I will present a little later as a technical solution. For our plan, we need a list of all available documents. We need a list of all linked internet sources. We need a list of languages of the documents, and we need a text field where we can insert text terms within all documents even for the linked archives. We have to add something to our working plan. The search functionality is not only for internal but external archives, which is a real challenging feature, not only for Google. But we define first the input of the keyword, which is done by a simple HTML form. So we send this term to an action file and evaluate it. Then we create a hyperlink, a dynamic one, to every linked archive to send the request. So this is nothing new. But now we let the external search engine start and search the term. We got the result. And the system now should check what to do with that. It could be a line in our table with our links inside the portal, or it could be the presentation of the output from the external archive when it is properly linked to our portal. Our working plan contains maps and travel routes because Humboldt's volumes are partially travel literature. So by using the Google Maps features, the user will find the travel route to the Americas described in the personal narrative of travel, his travel diary, together with several locations which are marked by place marks and contain descriptions and some chronology of when Humboldt visited these locations. Those locations can manually extract from the documents and presented as place marks in the geographical position by using the structure of the Google Maps application program interface. But, of course, this is the first attempt to this project. It is the presented map from the Humboldt portal. But for our working plan, the computer should harvest the location names and the coordinates automatically. It is not done by manually work, but it should be automatically searched. And as a connection to the Humboldt Digital Library, every place mark should contain a link button which opens a browser window which lists an online search for paragraphs where Humboldt described exactly that location or where the user could find more details about his observations. Do we have got technical solutions for our working plan? Yes, we have got some. To meet the referred requirements of the working plan, we created first the search option for text terms in external archives, which is implemented in dynamic hyperlinks to those archives, like as I described before. But we know that is necessary to handle a search request in the entire context, which is defined by metadata such as origin, thematical embedding, environment, geographical positions, and more. Instead of search terms, now we are dealing with objects, which can be formally named and classified by computer processes, defining ontological types, properties, interrelationships. In addition, logical connections like synonymous terms and hyperlinks to comparable internet information must be correlated to those objects too. And following those requirements, we started to define dynamic hyperlinks as flexible, at runtime generated objects. The building process of a hyperlink object depends on which function will be used. For example, searching or viewing a document's text. And of course, external archives cannot use object-oriented data. They need textual terms as keywords. Our approach is embedded inside this portal. Some technical things. The aim of this portal is not to reinvent the wheel of a digital library, of course, which is internal data storage, but more the building of a linked information network which consists of different information sources and archives. Initial success has already been gained with the implementation of an archive cross-search feature. The search results are listed together with supplement links to the original sources, which enable rapid access to the search functions of the linked external archive. Depending on the availability of interfaces of these archives, the search term can be directly transferred to start the search in the original document. All successful actions lead to object-oriented structures in our storage. Whenever a term is detected, the web crawler checks and analyzes the usability of the harvested information and inserts the object data into the system. The scheduler gets the search term from the portal, selects the existing data from the object storage. If there are usable data, the source will be used to access to the source with the known methods and formats. Otherwise, the crawler starts its action with the wrapper and analyzer are described. Okay, some more technical things. The web crawler now is enabling the analysis and data processing of terms and definition of object-oriented structure. All terms are converted to text objects which then were expanded by parameters and properties. The parameters are used to define autocomplete function for the search input, to find synonyms, to identify translations of terms or paragraphs, or to assign locations which we use for the Google map. To improve the geographical feature, the names of many places in the works of Humboldt were semi-automatically extracted and linked to Google Maps. In this process, the content of his writings was checked against a location database named GeoNames, whose location data were filtered first by GIS with their geographical coordinates close to the travel routes of Humboldt. Selected location names were automatically checked and compared with names Humboldt ever used in his documents. In case of success, the result will be interpreted as relevant location name and will be generated as the place mark in Google Maps, containing the corresponding text paragraph in Humboldt's writings. Finally, the generated information will be submitted to the Google Maps application program interface in the portal, together with the geographic orientation, the Google Maps, and the georeference overlay match from Humboldt in the slide presented as the map of Mexico. The extracted location objects can be used to go into details of the descriptions because every place mark, you could see here, is presented together with a dynamic link, so the search in the library can be started directly out of this map. The overlay maps can be used to find location, regardless of identical place names, to identify geographic observations of Humboldt, to compare landscapes from 200 years ago to more recent ones. To go into details, we improve the internet services and get closer to the true visions of Humboldt. We used our object-oriented structure of the text documents to create more dynamic hyperlinks to other sources, which could provide potentially relevant information. One of those external sources is the knowledge-based information system called Wolfram Alpha. It is an online service developed by Wolfram Research that answers factual queries directly by computing structured data. In comparison to Google, the results of the request are presented in the classified form, which depends on the recognized form of data structures such as object property. Much like the aims of our development of the knowledge-based Humboldt Digital Library, the developer of Wolfram expressed that one goal of this project is to collect and accurate all objective data, implement every known model, method, and algorithm, and make it possible to compute whatever can be computed about anything. Well, I do not believe that, but it is quite helpful to use this option or to use this program. It is promising, and the availability of this product is what makes it possible to implement these services into our own developments and take advantage of its capabilities, as shown in the slide with the information cycle of the Wolfram Alpha implementation. So the scheduler of my portal generates and sends a query of Wolfram Alpha's knowledge base. Wolfram Alpha computes the query with information stored in their databases and returns the answer to the portal. Finally, my scheduler sends the result to the portal's presenter and checks what to do with this information. This opens the option of automatic classification of text, which we included in our portal whenever a user is using this portal and inserts a term to the search engine. First, the system is checking the occurrences inside the text of the internal and external documents. Secondly, a dynamic hyperlink will be created to access to the external archive, which was identified as the source of the found document. Well, this technical approach gives you exactly an output of the portal as you could use and as you could access for free on this website. So you see here the importance of this development. We have at our fingertips all relevant information and text terms, notations, measurements and observations Humboldt ever described in his works. The answer of the Humboldt portal is to a search request is now can be presented as a list of documents from internal or external archives which are containing terms as the text information. If the automatic classification process of portal and Wolfram Alpha service recognize the classified object, the output can be different and possibly will lead to additional information. So you see here, this is the output from the Wolfram knowledge base. In every case, the result of this research will be a list generated by the presenter. This concept is what we call hypertextuality. Based on this concept, the Humboldt portal can be used as an example of, for interconnected hyper-searching, which cannot be done only today by Google search. Sorry for those, maybe you are Google representatives here in this room. But the result of our work, we defined a working plan to create an internet portal for comprehensive access to Humboldt's writings, and regardless of the document's digitized formats on online archives such as Google Books, Internet Archive, Deutsches Textarchiv, Bibliothèque Nationale de France, and others. The portal contains a system of web scheduler and web crawler which analyze search requests, create object together with object classifications by Wolfram for successful request, and presents the data as a dynamic hyperlink or output the link for the linked archive. So we can provide comprehensive search, link to suggested archives, autocomplete lists, analysis of expected results, deletion of word separations in text, the mess in digital libraries, maybe you know, detection of misspellings, object classification. It may occur that the user isn't recognized the system behind the Humboldt portal, and we made the experience that some users are complaining about the results of detected terms, which cannot be found in the external archive. But we know they are there when they are linked in our table. But we cannot improve, of course, the search engines of external archives. This is the problem we have got. And now, let me finally resume. We accepted the visions of Humboldt to decover internal forces and the interconnectivity of nature as recent concepts to develop internet-based knowledge bases as online archives. So we created the Humboldt portal with implemented methods to provide these documents and links to relevant internet sources as external archives or digital libraries. Additionally, we added object-oriented features, dynamic hyperlinks, and object classification by using the linkage to this Wolfram knowledge base, which altogether opens innovative options for better understanding Humboldt's vision of nature. Following the Bloom's taxonomy, we are dealing with lower order thinking skills by remembering and classification of objects. To reach higher levels of artificial intelligence, we must work continuously on more dynamic hyperlinking, decoding of multilingual text terms, decoding of images and data tables, and the automatic generation of ontological structures, which enables a hyper-searching of interconnected information. Thank you so much for your attention.